So I'm giving you cotangent of the angle equals 1 over x, and then you would know what quadrant to draw that in. Martin, what quadrant does it have to be in? First quadrant. I'm drawing a short, fat one because then I can believe what I label the sides as. You know, otherwise, if you make it long and skinny, all of a sudden some side combos are just not believable. The cotangent is, how am I supposed to know what cotangent is? Well, you can remember cho shot cow, but you're not going to probably actually use that. You're instead going to change this to tangent of the angle. And if I flip that to be tangent, remember that's flipping it, then I'm going to flip that to be x over 1. And I'm keeping the over 1 because I like having two sides. All right, so then tangent, TOA, opposite, adjacent, x1, and then that third side. Vivian, what's the third side gotta be?
Square root of x squared plus 1.
Yep. And I know you're tempted to say 1 squared, but 1 squared is 1, so you chose wisely and just said 1. All right, cool. Then I got all three sides, and then if the question were sine of the angle is what? It'd be pretty easy. John, what's the sine going to be then?
X over square root of x squared plus 1.
Yep. How many of you feel like you have that kind of problem under control? That's the vast majority of people. Good. Then let's just talk coterminal for a minute. That's pi, right? You might think, well, there's only one way to get there. You go like this. No, there's quite a few ways to stop right there. Remember, the key word terminal means stop, basically. So there's quite a few ways to stop right there. Would you please name me two more ways to get there? These are called coterminal angles. They're angles that terminate in the same spot. You might be like, well, I'll just do it in degrees. That wouldn't count. In this test, unless you're told otherwise, you got to give all your answers in radians. So since this one was in pi radians, you have to give me answers in radians. All right, please compare with the person sitting next to you. Okay, so these next few minutes are going to be fraught with, like, I finished in 2 seconds and I'm waiting for these other kids. So I want to give you this weird assignment. I need you to pay attention to me when I'm doing something new. But when there's work time, if you've already finished the question we just did, go and work on the Schoology quiz. There's a Schoology quiz. It's pretty easy, okay? And I'd like you to be comboing, do the problems with me when I'm doing them, but if you're done or you're just completely stuck on one, go work on the Schoology quiz during this time, okay? Because that's part of your homework for tonight is that Schoology quiz, but you're going to finish it in class. It's pretty easy. In a few minutes, if you haven't opened the Schoology quiz, I will be complaining in your general direction. So get it going. Okay, Alex K., can you give me one of the ways you could get to this red spot? Coterminal. Negative pi is a good one. Now give me another one.
3 pi.
Ah, 3 pi, he says. I'm going to double check him. That's 1 pi. That's 2 pi. That's 3 pi. It stops in the same spot. 3 pi is also correct. All right, good enough on that. Now this spot is not pi at all. But if I asked you to find that angle, just one name would be fine. Would you agree it's 3 pi over 2? Then what's the sine of 3 pi over 2? Now, some of you right away think, okay, sine is opposite of hypotenuse. You can't do that. On this kind, you can't do that. You need to know this point down here. This is one of the reasons we had to teach you the unit circle. I mean, I guess we could have actually just taught you the graphs of these and you could have got it off of that, but that would be much more complicated. The unit circle has 4 spots that you can only do like this. They're called the name them. Quad what's? Quadrantals. In case you forgot, these 4 spots are called the quadrantals. 0, pi over 2, pi, and 3 pi over 2. And this is also 2 pi. But if you're given a choice between 2 pi and 0, you always pick 0. Because it's cleaner, simpler. Okay, next. What is sine of 3 pi over 2? Well, that requires that you know what the 4 points are. This point right here would have been 1 comma 0. Why do I need to know that? Because sine is the y, cosine is the x, and then a lot of people get tangent upside down. What is tangent? Y over x. Very good. Okay, so would you please figure out sine of 3 pi over 2 by using that unit circle way? I'm going to pause for a second. And again, if you're already done, you're like yawn, then go work on the Schoology quiz. Okay, so this spot was at 0 comma negative 1, and sine is the y, and therefore it was just negative 1. Okay. Now I get it's going to be hard to switch back and forth, but I need your attention again. So stop looking at the Schoology quiz, which I'm glad you were working on it, but I need you to try this one because the Schoology quiz is too easy. It's going to be a lot of easy ones. These are the tougher ones that you got to know for your test. So if I said sine of pi over 6, how many answers is there for that? Yes. Nope. Because pi over 6 is only one spot. Pi over 6 is right there. There is only one answer for that. Okay, but that's different than sine of some mystery angle is 1/2. How many answers are there for that? 2. All right, let's make sure you get this. Everybody to start with, just do sine of pi over 6. Take your time. I know some of you memorized it, but just draw out the triangle. Put the sides on there. This is a very important basic. You got to be able to draw your triangle in the right spot. And sine is, well, this is pi over 6. So then if that's pi over 6, then this is 30. And then that's a 30, 60, 90. And right across from the 30 is a what? Say it. 1. And this is 2, and this is square root of 3. And there's no negatives because we're in the all students take calc. The A quadrant, all positive. Okay, so all of the functions, sine, cosine, and tangent, are positive there. So sine is the opposite of right hypotenuse, so then it's 1 over 2. Once you get the triangle drawn, it's so easy. All right. Now I'd like you to just do another one on the same one, except we'll do a different quadrant that we haven't messed up yet. I'd like you to figure out what's cosine of 7 pi over 6. Cosine of 7 pi over 6. Draw the triangle, put the sides on there, figure out the cosine of 7 pi over 6. Okay. Molly, which quadrant do you think we were in?
3.
Quadrant 3, very good. So I'm drawing it. I'm not sure what it is, so I'm going to make it short, fat, triangle. Actually, I know what it is, though. It's pi over 6s. So I know it's a 30, 60, 90. So I can make it small. And this is a 1, and this is a 2, and a square root of 3. I've made multiple mistakes, but I'm getting closer. What's my one mistake I have left here? Negatives. Opposite, opposite. Now, cosine, adjacent over hypotenuse, negative root 3 over 2. Who had negative root 3 over 2? Okay, good. All right, then let's do one in this fourth quadrant here. Let's do cotangent of 7 pi over 4. Right away, cotangent, you should say, I'm actually going to not be using cotangent. I'm going to be doing tangent, but then flipping it. So everybody figure out cotangent, 7 pi over 4. Draw the triangle. Make sure you got all the sides, all the angles. And then it won't be that hard. Pausing. Okay, so here's another type of question. I think we answered this one. Maybe I forgot to record the answer. The answer to that one, after you draw the triangle, was a tangent was negative 1 over 1. So you flip it, it's negative 1. Okay, back to this one. We have an arc length of 8, an angle of 70, and I'm asking you for what's the radius? So you know this, or at least you can find the radians, and you know the arc length. You can put them in the formula. and solve for r. Now, there's no calculators in this test, so I'm okay with this answer. Just simplify it as much as you can. You don't have to get me a decimal. All right, the arc length is 8, so 8 equals the radians. Well, I have to do this, multiply to figure out the radians, and then I'll solve for r. All right, so Graham, can you tell me what's that little magical thing I multiply by to get my 70 degrees to turn into radians?
180.
You are close.
Pi over 180.
There you go, pi over 180. And how did you instantly know you were wrong? When you realized
Because
your degrees need to cancel. Very good. Okay, so then I can chop off a 0 on the top and the bottom, simplifying it down to 7/18 pi. That's in radians. 7 pi over 18. That's my angle. So then, that's 7 pi over 18. Now I like to clear fractions. It's one of the biggies. If you could factor it, you should, but otherwise, next up is clear the fractions out. And now, if I can get rid of that 7 pi, I'll have the radius alone. I'm going to divide both sides by 7 pi. 18 times 8 over 7 pi. That would be 8 times 10 is 80, 8 times 8 is 64. 144 over 7 pi. Okay. One more. Sector of a circle. Say the radius is 10 this time. Say the angle is 60 degrees. What's the area of the sector? Now, there's a formula for this. You're getting too hot. You gotta warm up, or you gotta cool off, otherwise you're gonna just fight sleep for the next half hour. Okay, there's a formula for this that I'm gonna tell you because we're gonna give you the formulas anyways. And it's the degrees out of 360, or couldn't that have been in radians? If it was in radians, it'd be out of 2 pi, not 360, okay. And then times pi r squared. So the formula in radians is the radians out of 2 pi times pi r squared, but they cancel the pi's, logically, right? So if you do it in radians, it's the radians divided by 2 times r squared. And if you do it in degrees, it's degrees out of 360 times pi r squared. If I give you the formulas, this should be like way too easy. So take a second, get it done, and then go back to that Schoology quiz. Okay. Degrees out of 360 would be 60 out of 360, and the radius is 10. So I'm going to go simplify 60 out of 360 is 6 out of 36. Oh, that's going to simplify again. Times pi times r squared is 100. And then I'm going to reduce this to 1/6 of 100 pi. And then that can really be 100 pi over 6. And I hope you also simplified it down more. 50 pi over 3. But I think that might be it. Did anybody else get 50 pi over 3? Yay, you did it right. Okay, so that's area of a sector. How about speed? Now, if I have a circle and I just tell you the radius of it, if I tell you the radius of the circle is 10 inches, and I say that this thing is spinning around at 10 rotations per second, I want to know how fast it's going in feet per minute. How many feet would it go in a minute? Well, the thing that's going to be hardest is you'll eventually go, well, I got to know what a rotation is. But isn't a rotation the same as a circumference? So we would need a formula for circumference. Some smart kids got this memorized. Circumference is, this is one of those things for the ACT that would really, really help is if you memorized formulas because they don't give you a formula sheet. Who's got circumference? It's not pi r squared. That's the area. What's circumference? Yes. 2 pi r. Very good. Or pi times the diameter would also have worked. With those two formulas given, you should definitely be able to figure out what a rotation is, because then you can cancel it. One rotation is, well, you figure it out. And then the rotations will cancel. All right, I'm going to pause for a second while you try this one. Okay, so here's how this one works. You need to figure out what a rotation is. A rotation is the same as a circumference, and a circumference would be 2 times pi times r. I'm going to use that one because I have the radius, and the radius is 10, so that's 20 pi. 20 pi, I got to get units, though. It's all about units on these. 20 pi inches, yes. So now I got inches per second. I'd have this times this, be inches per second, but that's not what I asked for. I asked for feet per minute. So then I got to get seconds out of there. This is the best way to do it. You go, I want to get this out, so I'm putting seconds up there. I know 3,600. I know some of you would have just went with 60 seconds in 1 minute. I'm going to do 3,600 seconds in 1 hour. And then these will cancel. And now I've got inches per hour. But I wanted feet per hour. So last thing, I want inches out of there. So I put inches there right off the bat so that these 2 inches here can cancel each other out. And then that's 12 inches is 1 foot. Inches cancel. Feet per hour. That's exactly what I wanted. And since there's no calculator, I'm going to let kids leave their answer like that. So on the top, I'd have 20 and a pi and a 10 and a 3,600. Feet per, and it's 12, just a 12 down on the bottom. Otherwise, they're all ones. I could simplify that. I can get the 2 to come out. 2 times 10. 2 times 6. I could probably simplify it even more. And I'll probably tell you to simplify it as much as you can. That was close anyway. Okay, so many kinds of problems to do on this test. But if I had to only pick one that you had to know how to do, it would be sine of some angle equals negative root 3 over 2. Cosine of that angle is greater than 0. All that means is it's positive. That just locked down what quadrant you had to be in. My question isn't what's the angle. It could be, but I'm going to say what's the cosecant. No, that's too easy. What's the secant of the angle? Because, see, this makes you know all 6 functions. It makes you know where to draw the triangle. It makes you know the 30, 60, 90 triangle. It makes you know so many things. So try this one. Remember that once you've got it drawn in the right quadrant with all the right sides on it, the rest should be pretty easy. I'll pause while you try that one. Okay, so this is the part where I want to turn you loose on this worksheet, but I had a good question that I want to end with on the video here. On the worksheet, the Chapter 12 review problems, that's what it says on the top of the worksheet. On problem 5, it says this: 0 is less than theta is less than or equal to 2 pi. That means that they're saying your answer has to be bigger than 0. Do you get that means the answers can't be negative? That's just a fancy way of saying no negative answers. And the answers have to stop. The biggest answer you could get is 2 pi. So you can't say things like 7 pi is your answer. The biggest you can have is 2 pi. So basically they're saying you're going to stay inside this circle, and the biggest answer you could ever give is 2 pi. All right, so that's what this little thingy means, is don't give negative answers, and the biggest answer you'll ever get is 2 pi. All right, so then if cosine is root 2 over 2, do you recognize that one right away as one of those things that's been rationalized? That's what I think of. I think right away, root 2 over 2, oh, that was the one that would have been 1 over root 2, but they rationalized it. That's another tip for problem 5. And so then I go make my little thing and say A, S, T, C. Why would I say that? Because I know it has to be positive. Cosine of this thing is positive, which means I can't be here and I can't be here because cosine wouldn't be positive there. Now I've got it down to 2 places where you can draw a triangle and you can label it with these sides because that'll be a lot easier. Now you could have gone the other way and used root 2 and over 2, but I personally think you'd be better off to recognize that that's just a rationalized 1 over root 2. So now from here, you need to draw your triangle in the right spot. Remember, you can always look at the answer key for this, but. All right, it's my last tip of the day. Make sure you do this review worksheet. It is assigned. You are going to Dropbox a picture of it at the end. I'll remind you right before you take the test. Okay, so this counts as homework and really, really smart to practice tonight because this test could just be over with tomorrow with a straight A. If you bomb it, you'll end up having a retake, which will take 2 hours. I'm telling you, study hard first night.